Good morning, everyone. Welcome to the EasyPower Refresher webinar series. My name is Jim Chastain. I'm an applications engineer here at EasyPower. The title today I think is a little misleading. I think I could have done a better job of describing what we're going to be talking about. We're labeling this What Happened to Cat 0 and Low Voltage Exception. More accurately, what I'm going to be talking about is the EasyPower options to deal with these changes or these conditions that you may be faced with during an arc flash study. At any rate, thank you for attending. Here's what we're going to be covering, basically a brief historical background on a couple documents that are changed or updated at an irregular basis, NFPA 70E and 1584, and where some of these anomalies, if you will, arise, and then specifically alternatives that EasyPower can let you access when you're solving these situations. So as we are in the habit of doing, we would appreciate your participation in a couple poll questions. There's no downside, there's no liability, no obligation, but if you would please kind of respond in kind. First question is, how often do you utilize the 2-second rule? And again, some of us haven't been exposed to it yet. Some of us may have questions about it, and that's the reason for kind of putting it on the schedule today. All right, it looks like we have a quorum. Here's how folks have weighed in on it. So it looks like a majority, at least, are aware and utilize it quite a bit. We'll go into the details of that, but as importantly, we're going to be covering situations where it doesn't necessarily help. So stay tuned. And then the next question is, how often do you see instant energy on 208 voltage buses or equipment that's actually higher? The instant energy calculations are higher than 480 volt buses, which may be upstream. Again, this is something that may apply often to the type of circuits that you work on, and in other times it may not apply at all. So again, I'm focusing more on the EasyPower alternatives that you're presented with rather than judging or making any assessment of the standards that we are offered or available. Okay, it looks like we have a quorum here. It looks like we have kind of a weighting towards don't really care. That's just fine. Some of the techniques I'm going to be talking about apply to other situations, so appreciate your feedback, and let's get on with the presentation. So prior to the 2015 version of NFPA 70E, and I mislabeled this NFPA 70, which is the National Electric Code. I'm actually talking about NFPA 70E. We were giving several different what were referred to as HRC or hazard risk categories, and based upon the energy level that we calculate for a certain bus, that would tell us what HRC category to go to for PPE. Two significant category offerings in this choices were 0 to 1.2 calories per square centimeter and greater than 40 calories. Greater than 40 calories was do not approach, do not do hot work, and the 0 calories was basically a minimum PPE rating. Well, with the advent of the update, actually started in 2012, but with the 2015 version, there was an emphatic suggestion that we do not use not only this table, but we don't even use the description HRC. And so that kind of left some of us in a quandary because we had patterned our safety manuals after this description in these categories. So there was some light at the end of the tunnel in the use of a site-specific category. And so I've covered that in the previous discussion. But what we have now, and it's been carried forward into the 2021 version of NFPA 70E, is a 2-tier table for describing PPE for different ranges of instant energy. The one is 1.2 calories to the 12 calorie range, and the criteria is we've calculated instant energy, then the PPE that we select must meet or exceed the calculated value for the bus. And by the obvious exclusion of less than 1.2 calories per square centimeter, folks doing studies were kind of left with a quandary over how to handle this category of less than 1.2 calories. The point is, I guess the concern, and my observation is, what does it mean? Does it mean you don't need protection? And so if you allow me a couple seconds of regression, 1.2 calorie per square centimeter was derived and is defined as the arc flash boundary, and more specifically, the distance from the arc source at which the instant energy equals 1.2 calories is the arc flash boundary. Now that number and that criteria came from a study that was done by Alice Stoll back in the mid-50s and was titled Skin Damage from Heat Flux Exposure. And the table that she provided, or the criteria that was provided, has several different levels, actually a continuum of exposure and heat flux, and how it correlates to skin damage. And the 1.2 calorie per square centimeter boundary or level of exposure was that which, for unprotected skin, presents a 50% chance of the onset of second-degree burns. Now, this is blistering in the definition of the different categories of burns, and the criteria I surmise for choosing this point was that most of the time you can heal from sunburn that bad that has blisters without scarring. So I read between the lines, or I'm second guessing that's where they chose this particular level. So it still doesn't answer the question, what do we do with this category of less than 1.2 calories per square centimeter? In reality, it really comes down to what position management wants to take with respect to hot work. And many folks basically say, yeah, there's a need for PPE, but we don't want to deal with the criteria or the piecemeal approach of it not being covered in the standard. So we're going to enforce it by the way we train our people and the way we label the equipment. Now, I want to point out, labeling and whatever's on the label does not authorize hot work. So an instant energy of 1.2 calories or less than 1.2 calories per square centimeter at a working distance of 18 inches may require additional PPE when work is done on that bus, because the working distance may be less than the 18 inches that's used to calculate the label data. Okay, so with all that in mind, the alternatives basically, in many cases, manufacturers just say, okay, we're going to establish a daily wear criteria for people in qualified workers with a rating of 4 calories per square centimeter, which will eliminate the concern. We're just going to label everything as the actual instant energy, and then only allow qualified workers to be in the area if that panel is going to be removed. And so this seems like a fairly reasonable thing to do. Now, otherwise, some people say, well, I want to show a minimum calorie level on the label, for instance, a 2-calorie minimum, and then that way no one approaches it at all, and I don't have to worry about qualified workers, visiting contractors, whatever. Everyone knows that they need to have on a minimum PPE 2-calorie. Well, in EasyPower, we can do this in a couple of different ways. We can force a bus to show or calculate out to 2 calories per square centimeter, and then the other one is to put a minimum PPE rating on the labels themselves. So let me jump into EasyPower and let's kind of walk through what this may look like. And as I do this, you may want to keep an eye on some of the other things I've implemented in this particular file. Okay, so here's a campus layout where I have a ring bus, and I have set up under name views the different buildings that are part of my campus. And so for the physical plant, if I go in and look at the instant energy on this particular bus, I can see it's less than my 1.2 calorie rating. So if I want to force this, I can do so on the description of that particular bus in Database Edit. As I open up the Database Edit dialog box for the panel itself, I go to the Arc Flash Hazard tab. I have this arc flash bus. Arc flash for this bus can be calculated, which is the normal setting, excluded, which I would do on buses that I didn't have a concern, like the utility bus or whatever, or I can force it to a specific level. So if I wanted to basically put 2 calories per square centimeter at an 18-inch boundary on the label, I would do this. And now when I go back to short circuit focus and fault that bus, you can see my indicated energy levels at 2.0 calories. So that's one way of basically forcing the bus to that level. And as I look at it, I can see that that's indicated in my instant energy results because there's no details as far as the calculation. Another way to deal with it is to put a minimum rating on the label itself. So for instance, if I go back, let's go to this bus, fault it, if we have 0.3 calories, as I look at the label editor, all the labels are connected through the arc flash hazard report. I go to the label editor, I can set up a template that is based on some fuzzy logic built into the label editor that shows a minimum rate. And so to show how this is controlled, I go into Label Designer, start the editor, and what this shows me is for this instant energy value, I can make it conditional upon instant energy. So for any instant energy less than 2 calories, I want to indicate on the label a 2-calorie value. And in this particular case, the policy was, okay, if it's less than 8 calories but greater than 2, put 8 calories on the label. And then further on, if it's greater than 8 but less than 40, put 40 calories on. And if it's greater than 40, make no hot work available. So again, we're implementing a policy of a minimum PPE to be utilized. And it's not only trained to the employees, but it's reinforced with the way we present the information on the label itself. So that's a minimum instant energy and how to cover 1.2 calories or less than 1.2 calories in various situations. Now the other thing that's kind of evolved, and this is part of IEEE 1584, in the 2002 version, which is when it was originally introduced, it had what was affectionately referred to as a low voltage exception. And this in detail described equipment below 240 volts need not be considered unless it involves at least one 125 kVA or larger low impedance transformer as part of its power supply. And the reason was, while the accuracy of the model is not as robust at 208 volts as it is at 250, it will work and will yield conservative results. The arc flash hazard need only be considered for large 208 volt systems. So anything smaller than 125 kVA should not be concerned. Basically, they were disregarding 240 volts or less if it was supplied by less than 125 kVA. Well, in subsequent testing and the release of IEEE 1584-2018, this was no longer included in the documentation. Now, it's not as a result of this, but in conjunction with that change, in 1584, another paragraph, if you will, that's affectionately referred to as the 2-second rule, appeared. It originally was in the informative annex in the 2002 version, but the fact that it's moved to the body of the 1584 standard encourages us to call it a rule. So what it amounts to is that, and it's basically considering a human factor, not necessarily any calculations. And basically it says if the total protective device clearing time is longer than 2 seconds, and as a result, the instant energy is high as a result of that clearing time, then consider how long a person is likely to remain in the location of the arc flash. In other words, if an arc occurs in our face, more than likely the human nature is to jump back or get out of the way. And so it's reasonable to assume that it's likely for a person exposed to that arc flash will move away if it's physically possible and limit the calculations to 2 seconds for that energy exposure. And I've kind of talked about this when we talk about different videos, but the bottom line is if I have high incident energy, and usually it's because of low arcing current, then there's still a potential for an arc, but it's not going to be something that's going to consume one in the conflagration. And as long as I remove myself within that 2 seconds, my PPE is going to be adequate. And this turns out to happen more frequently at lower voltage than at the higher voltage range. So the result of this, removing this low voltage exception, was that panel loads of 240 volts or less should be included in arc flash hazard assessment, independent of the energy supplied, as far as the description in the standard. And at the same time, because of the removal of the exclusion, there's a potential for higher incident energy on 240 volts at this 2 second point than on 480 volts. Okay, we'll take that half step further, and I want to talk about, so basically, those of you that haven't heard of the 2 second rule, when you see me get into EasyPower again, I very frequently I'll see 2 seconds applied across the board, and the only reason I drag my feet on recommending that is that potentially it could interfere with my coordination. So before I do a mass limitation of 2 seconds across the board, I suggest making sure I have the coordination figured out for my system and the downstream loads before I start limiting any calculation period. Okay, let me take that discussion now further into what is usually referred to as arc sustainability. So the problem is, at low voltage, there was limiting testing, even at the original standard and since then, as far as developing the model. But there are several papers that describe low voltage testing, and it's believed, or it's been proven, shown, that arcs with less than a 2000 amp available fault current will not actually even self-sustain for 2 cycles. So the point of this is that if I have that situation where I have calculated my arcing current, available voltage fault current, to be less than 2000 cycles, more than likely that system will not sustain an arc if it were to form for longer than 2 cycles. It will self-extinguish. Net result of this is, okay, well, the 2 second rule is way overkill for what's going on. In fact, in many of these situations, you'll see limiting the 2 seconds gives me an incident energy calculation of greater than, in a 240 volt system, greater than the energy that is in the system at the 480 volt range. So what I'm about to go through, and I've talked about this in the past, and people took it as a recommendation. It's not a recommendation. What I'm about to describe is not a recommendation from EasyPower. It's outside the guidance of 1584, but it is within the purview of someone looking at an sound engineering judgment based upon some of the guidelines that I will list at the end of the presentation. This is an excerpt, and admittedly, you should look at the papers yourself, because in fact, I'm cherry picking to show only these results, but what they showed for calculations of 240 volts and less, if I had an arc current of less than 2000 amps, the arc would not sustain itself more than 2 cycles. And so these are 2 different plots, one based upon different types of bus work, different materials, and the other based upon different gap settings. These are pretty common in typically 240 volt panels. Now, the point I'm trying to make is, if in fact I have a situation where the arc won't self-sustain for 2 cycles, then in reality, my arc time is going to be somewhere in the neighborhood of 33 milliseconds. And so it's possibly advisable, at least, that using a half-second limit rather than the 2 second limit for max calc time gives me a guard band of over 15 times on those types of equipment. So let's go back to EasyPower and see what this means. So I'm going to pick up another building here. And here we have some 208 volt loads downstream of 480. I'm going to go in and fault all my buses, calculate the instant energy, and I can see on my 480 volt loads I've got less than 1 calorie, but I have greater than 1.5 calories on my 208 volt system. If I look at the voltage fault current, you can see that it falls into that category of less than 2,000 amps. Now I've already taken the step of doing my limit for 2 seconds. And what I mentioned earlier is I literally see people limit 2 seconds across the board, and I recommend that only if you've already calculated your or completed your coordination. But you can see this doesn't change much my instant energy on the 480 volts. In fact, it doesn't change it at all because I have protective devices that come into play, and it doesn't change my 208 volt system. So what I'm trying to point out, if I go back to the Arc Flash dialog box for this particular panel, that in my humble judgment, looking at the current that's involved, I have justification for limiting the calculation times using a user-defined time of 1/2 second for just this particular system. And what that now gives me, if I go back to short circuit and fault that bus, of an instant energy now more in line with a significantly reduced amount of arcing current and time. So again, this is not a recommendation. This is a situation where if you have a problem with the 208 volt system being higher energy than my 480, look at the current involved, and if it's in the 2000 amp range or less for that fault current, you may want to consider this time restriction as part of your solution. Okay, hopefully that made sense. So what we've basically talked about is how to implement a PPE policy decision with standardized daily wear or a forced calorie level at a local bus, or using the logic in the label printer to put a minimum label on the piece of equipment. We discussed how to apply the 2-second rule. Again, it can be applied universally or globally, or it can be applied individually to buses based upon how I feel about the overall system, or how I as the engineer in charge. And then finally, we discussed the minimum arc sustainability on buses less than 240 volts. And as I promised, here's a list of some of the papers that have been presented that discuss this sustainability issue, and I invite you to do a little bit of research if this applies to you. Thank you all for attending. If there's any questions, be happy to follow up, and certainly I look forward to seeing you all again in future webinars. Thank you for attending.